Alrighty, we should be live. Again, the microphone's going to be a little weird because I'm waiting for anyone to to come in, but so we're working with the built-in mic in my MacBook, so that's fine. Just gonna ping the Discord. Going live on YouTube. Again, I still am waiting on an Ethernet cable to come in so that I can go live on Twitch and YouTube without network issues. So stay tuned on that. So for today's stream, the plan is to wrap up the binary search tree implementation and go to the last project with this Knight's Travails project. So I already was thinking about this actually. So I already have an idea about how I'm gonna implement this project, maybe. Just after doing a little bit of reading on my own time. So anyway, I also did some research on node deletion in binary search trees, and I was almost correct with this, except I forgot one case. So this code should work. The only problem is we need to make like a sub function within here to do an important task. Because, okay, so when we find the node to be deleted, there's three cases, right? The node could have 0 children. Like, so it's zero, like it would be a leaf node. It has 0 children. It could have 1 child, or it could have 2 children, right? And the 2-child case is the most difficult one to address. Hold on, let me just there we go. I was just going to the Discord to check something. Yeah, so we're gonna do those 3 cases. So let's say we get the node left and the node right. So we'll check if neither are available. So like if it's a leaf node, right? So leaf, then we don't really need to do anything in this case. Actually, yes, we do, because we need to remove it as a child from the parent, right? So we'll say if from left, then this is how I'm tracking whether, like, where the node is with respect to its parent, whether it's the left child or the right child. I'm just using a Boolean. There might be a better way of doing this. So I'll say if from left, then parent dot left child equals, actually I'll do if parent, and I'll just do it like this. If from left, then parent dot left child equals undefined, else parent dot right child undefined. So then we remove it from the parent. Remove from parent. Okay, so I'm gonna do else if. Actually, we'll do an else case here. Actually, I might want to handle these separately. There might be a better, more elegant way of doing this, but I think I'm going to do it this way. So I'll say if node left and not node right. So if there's only one child, node has 1 child on the left. And then I'll copy this for the right. Actually, I'll write the code first and then copy it. So then we'll say if parent, we'll say parent dot, oh, then we'll do this a similar logic here. Parent dot left child equals node dot left child. Parent dot right child equals node dot left child. And then the logic here is very similar for the right node. And then we just set it to the right child instead. Right? And then this is the case where node has 2 children on left and right. Alright, so this is the most complicated case here. Again, there's probably a better way of approaching this, but this is the way that I think makes sense. So what we need to do is we don't actually delete the node itself, because we need to replace its value with the leftmost value from the right subtree. Yo, anime, how's it going? I hope you've had a good day. So we have to find the leftmost child on the right subtree, delete that, and then replace the current node's value with that leftmost child on the right subtree. So we have to do that first. So we need to find leftmost node on right subtree. Right? And then, but the only tricky part is obviously this leftmost node might have one child of its own, right? It might have it might be a leaf node, or it might have one child. It can't have both, because if it had both, then there'd be another leftmost node to go to. So it might either have no children or a right child, right? So that's what we need to do. So we'll do that first. So we'll do that. We'll say let left. Well, actually, what should I call this? Let next node or something. Seems you streamed early. Yeah, I'm trying to, anime. I'm trying to stream earlier because I'm trying to end earlier as well, so I can spend the evenings with my girlfriend and get to bed at a better time. So that's kind of why I'm streaming earlier. Anyway, so we'll say, should we do like next node? Or say like leftmost equals node dot right child. And then we'll say while leftmost. We also want to probably keep track of the parent too. Let leftmost parent equal node dot right child as well. And we'll say leftmost parent equals leftmost, and then leftmost equals leftmost dot left child. Okay, so then we should have the leftmost child and then that child's parent, right? And then so what we'll do is then we'll say to check get value from leftmost node. So get value from leftmost node and delete it. Right? You didn't follow through, so I'm kind of not following. That's okay, anime. I can walk through. I can walk through the code again after it's done. This is a pretty inefficient solution, I think, because I'm not using recursion. I'm using iteration. So anyway, I'll walk through it again. I need to really have some sort of, like, I was thinking about this. I need to have some sort of like whiteboard or something to, or like some sort of app that I can like draw on easily, but I don't have a drawing pad, and it's pretty difficult to like describe like what I'm thinking using just words. But anyway, okay, so let me get value from the leftmost node and delete it. So what we'll do is we'll say let leftmost value equal leftmost dot value, and then we'll say if leftmost dot right child, then leftmost parent dot, I guess it would be from the left, it would have to be. Dot left child. Actually, I'll check if leftmost parent exists, and if leftmost dot right child, then leftmost parent dot equals dot left child. It's on the right subtree. Just thinking about this. Because it might be the right child, because the leftmost value on the right subtree might just be terminal. So to be careful about this. Recursion is, let's say a function is calling itself. Yeah, exactly, anime. So instead of recursion, I'm using loops, like this while loop here. So, yeah, recursion is a function calling itself. So an example of recursion, I think I have a recursive function in here somewhere. Yeah, like right here for building the tree. I have this function called BST recur, right? And then what I'm doing is I'm calling the function iteratively, or not iteratively, recursively, inside of itself to construct a binary search tree from an array. That's what this build tree function is doing, and we built this, and then here's the initial call right here. And we wrote this function yesterday, or I did, I guess. But anyway, so let's go back down to where we were. So we're going to need to check whether or not the parent is still the right child or not. So check if parent is equal to node itself as the leftmost would be its direct right child, otherwise it's left child. It's kind of confusing. Okay. So we'll do if leftmost, we'll check for equality by checking the values. Value is equal to node dot right child dot value. Right? And then, so you're going to scream and yell at me. think I can assert. No, I can't. Okay. Insert it here though. Node dot right child dot value, and that should get rid of the. There we go. Okay. Type checker is fine with that. Okay. So then, if it's equal to it, then we'll say that the leftmost parent. Actually, we'll just say node dot right child equals undefined. Actually, no. We have to check whether the leftmost has a right child. Yo, Nathan, how's it going? Just done a bit of classes in JS, bit till classes. Oh, nice. Like in the Odin Project? Okay. So, let's see. Yeah, no worries, Nathan. What's up? Okay, so we need to do... I need to check the leftmost dot right child exists as, and then we can do node dot right child equals leftmost dot right child. Otherwise, node dot right child is equal to undefined. And then the code here is very similar, except we do it with the left child. Leftmost dot left child. Or sorry, right child. Node dot, and then it'd be leftmost parent. Leftmost parent. Hold on, I'll get to your message in a second. This might not work. I might have to do a recursive solution for this. Left child. Property right child does not exist on type never. You actually did a bit of revision on classes in JS because you were learning about classes in TypeScript. Yeah, that's fair. Classes in JavaScript. Well, anime classes in JavaScript are just wrappers or syntax. What's the term? It's basically just like syntactic fluff on top of prototypes, right? For now, when you make an e-commerce website to add ratings, use an image of stars. So wait, so Nathan, do you mean like when you click like the stars, it like fills in the number that you give it? So like if you click like 4 stars, then it like shows that 4 of them are shaded in, or like 3, and then it shows 3 are shaded in. You'd have to do that with JavaScript. You'd basically have to put event listeners on each of the stars and have them each be buttons, and then basically what you would have to do is have all 5 of the stars inside of a div, and then using CSS or using JavaScript, you would have to like let me illustrate this. So let's say you have your stars in a div like this, and then you do like something like this, right? So here's your 5 stars, but instead of div star, these would be like images or something. So you could do, or like buttons, right? Let me actually change that. Let me do button. So these are like your 5 star buttons, right? Just for example, like imagine that you have an image in here, right? What you would need to do is you would need to have an event listener for each of these stars. And then let's say you click on the fourth star. You would need to set this star and all other stars that appear before it in the div to have a specific class that you could say like shade it in or something like that. And then when you add the class to these 4 buttons, then those in the CSS get changed to shaded in, right? And then also you have like a rating variable that changes. So like let's say I press this button, my rating is 1. If I press this button, my rating's 2, 3, 4, 5, etc. Right? But then you add shaded classes to the star itself, and then all stars before it, and then change the styling of that class in a CSS file. That's how I would go about it, I think. I don't know if that makes sense, but that's just like a little example. Okay, so let's see. I don't know why this is so I have to explicitly type this here. Although I know it doesn't have to be number or undefined. Leftmost is possibly undefined. Const. I'm not gonna lie, this is kind of crazy. Because this leftmost should be always defined based on this. Leftmost.left child. Actually, you know what I need to do? I need to do like a while true loop or something. And then I need to have a break condition. So I need to say if leftmost dot left child leftmost equals leftmost dot left child. Otherwise break out of the loop, right? I want to do both of these here. Oh wait. If this whole approach doesn't work, I'll probably end up doing a recursive solution, similar to what we had before. Okay, so this should be fine. So this should get the leftmost value. Bro, how do I practice TypeScript? I honestly just practice, man. I just try to build things. Like right now I'm implementing binary search trees, or a binary search tree object or class in TypeScript. Do I get the same satisfaction from hand coding something yourself or telling AI to do it? I get way more satisfaction MKM from hand coding. Way more. Getting AI to code something for me is like nothing. I don't feel anything because I didn't do it. I mean, I might be a little relieved if I'm stuck on a problem and then AI solves it for me, but I won't feel satisfied in the same way. Right? So I'm just dealing with typing issues here. Because I don't know how to assert that this exists. Can I just do this? Because I let this be number or undefined. So I don't know what the problem is. Leftmost parent is possibly undefined, blah, 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 blah. Okay, so what if I just... Okay, that gets rid of that. Okay, so this is good. And then number 3, set node's value to leftmost value. So we'll say node dot value equals leftmost value. And that should be it, I think, for the delete node. And there's no errors, so that's good. The keyboard has such a satisfying sound. Yeah, it's a Newfie Kick 75. I got it for a decent amount of money on Amazon. I like Newfie. It's a very good brand. If it's TypeScript, wouldn't you actually have to define the types, anime? So not always, because a lot of types can be inferred. Like, I actually probably don't even need this type annotation here. Like for instance, if like for this, if I say let node equals this dot root, the inferred type here is node or undefined because the type of this dot root is node or undefined. So in a lot of cases, when you define a function, or not define a function, when you define a variable, if you define a variable based on some other value, it infers the type based on what that other value's type is, right? So you can see that here. You can see like node is of type node or undefined because the this dot root value is node or undefined. So the variable being assigned inherits the type of the value it's being assigned to. That's a TypeScript thing, but in some cases there can be issues because if it's possible that a value is undefined, the linter does not like that. But anyway, yeah, back to the keyboard. I really like low profile mechanical keyboards because the thing is, I used to have a mechanical keyboard, but I don't like how much key travel there is on it. So I get a low profile one because I like the lower key travel, but I still like the clacky sound. I'm also working without a proper microphone. I'm using the built-in mic on my MacBook, so I apologize if the quality's not great. But I ordered a new one, so it's coming in soon. For advanced stuff, Odin's pretty good. Yeah, it is pretty good. Like, I would say this is like fairly advanced. I don't know. Maybe. We have to actually test that this works though. Yeah, basically anime. It's also if you have a custom type, it's important to define types. Like for example, if I wanted to make a custom type, that, like, let's say I wanted to make a type that only can store the values 0, 1, or 2, I could define that type by doing like type my type equals 0 or 1 or 2, and then I could like make a variable saying let thing equal 2. But if I wanted to make it specifically, because if I do let thing equals 2, right, this is going to infer the type of the value, which by default is a number. So thing will be a number, right? Right here, okay? But let's say I want the thing to specifically be my type instead of a number, I can declare it explicitly like this, right? So now thing is of type my type. And this is still a valid value because my type includes that value within its definition. So I don't know if that makes sense. But if I didn't include this explicit type annotation, the thing would be assumed to be a number, which is not what we want, right? It may not be the intended behavior. So, I don't know. That's the benefit of TypeScript. So, yeah. Yeah, the sound is great. Yeah, I would recommend it. MKM. Anything from Newfie is a good bet, and it's also not too expensive. Like I think I paid like 200 Canadian for this keyboard, which like is kind of expensive, but it's not like compared to some keyboards, it's like not as bad. Or maybe it was like 170 Canadian. I don't know. Probably like in American dollars, it's like 120 maybe, or 110. So yeah, I don't know. I'm happy with it. It's great for work too, because I usually do a lot of email writing and documentation at work, so it makes typing kind of comfortable. I'm from Canada, anime. I won't get more specific, other than I'll say that I'm from Canada and I am in the Eastern time zone. Because I don't really want to give away like my location or anything like that, like more detail, and I probably never will. Actually, I definitely never will, because I really don't want anyone in my real life that I haven't told about this to figure out my YouTube presence. Because with the kind of work I do, it could jeopardize my employment if my employer knew about this. So I'm gonna kind of keep it hush hush. But anyway, okay. So let's see. This should then theoretically work, I think. So we'll compile, and then we will run the development server. Yeah, exactly. Like I don't have huge issues with like any of you guys. Like if you knew my personal like identity, I wouldn't really care unless you were a bad actor. But like it's not so much that, it's more so privacy, so that I can. I mean, it's also good to be private online, but like also just for my employer. I work in a field that's very like my work's pretty confidential. It's related to the government, so I can't like, you know, disclose like exactly what I do. Like I'm in IT, I can say that much, but I can't like disclose like the data that I work with, for instance, right? Like I can say what I do, but I can't say like what it is that I'm working with, I guess. But anyway. So, alrighty. Let's see. This delete properly? It looks like it did. Oh no, it didn't. Not quite. Almost though. Okay, so let's test the different cases. So let's say, let's delete an end node like 6345. Okay, that worked fine. Or we could delete like 7. So 457. Yeah. So this, all right. So this, the deleting a leaf node works. I could set up like a test suite for this, but I don't really want to. Because I can just test it like this. All right. So that's fine. Yeah, I'm glad that you understand anime. Okay. So let's do a. Let's delete a single write. Let's delete like 5 or something and see what happens. Okay, so that worked. And then I can delete like maybe 9. Uh, 67, it's attached to 23. Yeah, so that works. I'm gonna add a 0 here to this. Or does it? -1 goes to 1. Okay, anyway, I'll just keep it. All right, so then the only issue that we're having now is the I think 324. Yeah, so deleting 0 or 1, or nodes with 0 or 1 children works, right? Because you can see, yeah, we deleted 324. So this is like pre-deletion up here, and then this is after deleting. So you can see that the 324 got deleted, and then the 6345 got attached to the 67, right? So that's fine. But then when we delete a node like 67 that has two children, right? It has a left and a right branch. I don't think it works exactly how it should. Actually, no, that seemed to work. Because then 324 is the leftmost on the right subtree. Yeah, okay, actually that did work. I think the only hiccup, like if we delete 4 maybe. 4 worked as well. Let's add a 6 in here, let's see. 5, 6, oh, and then the root's different, I see, okay. Okay, so that's fine. I think the only issue now is when we delete the root, right? We need to check that because we're reassigning, we need to make sure that the root is not. So we need to actually check that the parent is not the root. So we'll say if leftmost parent dot value is not equal to this dot root dot value. Because if it is the root, then we want to ignore this because the root obviously doesn't have a parent, so we don't need to reassign the parent's child if it's the root, right? So if we now delete 8, and that should, okay, so it almost works, but not quite. How do you know when you've learned CSS, for example, so you can move on to JS? I mean, if you follow the Odin Project MKM, you just kind of like do the HTML and CSS exercises, and then like once you have a firm grasp on the concepts that are in the curriculum, I would say it's more than fine to move on to JavaScript after that, right? At least in my opinion. Okay, so the problem is now is that the parent might be the root. Or actually the value itself might be the root. Right? Not the value, but the... So we actually want to do this. We actually want to check this one. If the leftmost value is not equal to the root value. Because if we're replacing the root, then we would expect the parent of the... Or not the leftmost value, sorry, it's node value. That's what we want. Although, okay, see, but now this is duplicated. Right, so that's closer. But basically, the only problem here, so we delete the node 8, right? And then we reassign it to the leftmost leaf, or the leftmost value on the right subtree. So the leftmost value on the right subtree in this case would be 9, right? And so the reassignment worked here, but we want to get rid of this node. So then the 67 just directly attaches to the 23. So that's the part that we are a little bit hung up on, right? So I think we actually just can remove, maybe just remove this. So maybe I was like tripping. No, okay. So we still need that check, kind of. Node to value, because we still want to assign the parent. Oh, here it's the leftmost parent dot right child. Or no, it isn't. no dot right child dot value, and then leftmost parent dot value is no dot right child dot value. Okay, this is so we need to delete this guy. So let's console log the. Actually, we'll just do it like this. We'll do leftmost parent dot value and leftmost dot value. So here we should get. Oh, did that not work for some reason? Oh no, it didn't. Because why? Because of this check. So we actually want to get rid of that. Sorry, I'm going like back and forth a little bit here. So 67 and 9. So it's the parent, right? So that got assigned to, oh, it was the wrong, I see. So it was the wrong parent. Okay. So maybe it's still the left child. Okay, well then what's the node child? The node value console. Yeah, it should be 8. So 8 should not equal 67. So this should fail. So leftmost parent is 67 here. And then it should be setting of the right child here, or the left child, I mean. So then this clause should be running. How's it going, Abdu? How are you today? Hey. I'm your motivator. I appreciate that, Abdu. That's what I'm here for. Okay, let's see. Let's see. What if we put like a breakpoint here, and then we refresh page. Oh, because I'm running the bundled version, so that's actually not going to work. I need to still get better at debugging. Keep doing the streams. I plan to, Abdu. I'm not giving up. Oh, again, I appreciate you dropping by and saying hi. Any motivation helps. But no, I don't plan on going anywhere. I'm gonna do this for as long as I can, and until hopefully I build something out of it or become successful or whatever. So I don't plan on giving up. Okay, so let's just do here something. Okay, so it's obviously it's running in this this. Yeah, okay, so it's hitting this branch, which we don't want it to, right? So I don't know why this is. Oh, because node.rightChild.value. Leftmost parent.value is node.rightChild.value. Although it actually would just be node.value, I think. I think that would actually fix it. Yes. Okay, now it's working. Okay, cool. All right. So now we can replace the root here, and you see it grabs the leftmost value from the right subtree, replaces it, and then reattaches here. Now, of course, I need to test this with a different tree structure. Because what we could have is this 67 could have no children, right? So we could like remove the 23, remove the 9, and remove the 6,345. Yeah, so then this works, I think. So we have, oh, we're deleting the wrong thing now. So it's 7, 9, 8. Delete the 8 maybe? 5, 9, 7. There. 400 subs, nice. I didn't even know. I wasn't looking. No confetti. And then we delete 3. Let's try deleting 3. This should work. Oh, it doesn't work. Interesting. Because it doesn't delete. Does not deleting 9 work? Not quite either. Because I would expect this 324 to just attach itself. So it's 67 is the leftmost to the right. And then, okay, so the behavior is not perfect here. But deleting the root still works. Yeah, it appears to. Okay, so it's just the, actually I'll work with the 3. So I want to delete if leftmost dot right child. It does not have a right child though. So it should be running this clause here. So I need to do some more writes here. Some more console log situations. Again, there's got to be a better way. Like I use breakpoints and stuff, but I don't know how breakpoints work when the code is bundled. So I'll have to learn better debug techniques. So I'll say console.log 1, 2. Oh, so it's neither of these branches. Interesting. Leftmost parent.left child. Let's print these out again. Do node.value leftmost parent, and then we'll do leftmost.value. Okay, so 3, 4, and 4. Leftmost parent is 4. Why is the leftmost parent 4? Oh. Okay, so it's hitting this. It's hitting this branch. So leftmost parent dot left child equals leftmost dot right child. Yeah, It's like very close to working. But I don't think either of these are true, because leftmost dot right child doesn't exist. So then leftmost parent, which is 4, because the parent is its own. Oh, you know what? Maybe we want the node to be the leftmost parent. That might work. Right. That's it. There we go. That's the behavior we want. Okay. So I think we figured it out here. Can get rid of these extra brackets. So then I think if I delete the 67 or 9 from here, it should work as expected. Yes, perfect. Exactly. All right, I think this works. I don't know if there's any cases that won't work. Yeah, and then we delete 5. And then we get 7. Yeah, 67, 30, 24. Yeah, it looks good to me. All right, I think we did the delete function. I think that's it. It's a bit convoluted, but if anyone wants me to walk through it, I can. But it does work, I'm pretty sure. Okay. Okay, so what was the next function that we need to implement? So we have the delete item, and we have the level order for each that accepts a callback function as a parameter. Should traverse the tree in breadth first level order and call the callback on each value as it traverses. 400 subs, yay. Iteration or recursion. A callback is required. You may want to use an array acting as a queue to keep track of all the child nodes. Oh, nice. Anime. Do you have, so you have 538 subs? I didn't even know. Do you do YouTube anime? I've never had this many subs on YouTube before. Not even close. Okay, so let's go down to level order for each callback. Should traverse the tree in breadth first order and call the callback on each value as it traverses. Yeah, but what's the callback though? Does it just like traverse the tree and then maybe log the value or something? I guess so. Yeah. So it's just a breadth first traversal. Let me just refresh here. Oh, I see. Okay. How's it going, June? Just on a little break here, reading a little bit about potentially what we'll do for this implementation. I'm just working through a binary search tree implementation in TypeScript. It's not quite web dev, but you know, it's part of the curriculum. How can you join me in my journey? Well, you can start just by maybe using my streams as a motivation to study. I don't know, where are you, what are your goals, June? Do you want to like become a web developer? Do you want to just get better at coding? Like, are you a student? Like, what are your goals? But you can totally join me. That's kind of why I started this channel. Be a hacker? Oh boy, that's a bit ambitious. No, I'm just kidding. It's not really what I'm shooting for, but I think as with any skill, like it's just about grinding and putting in the practice. Yo, JMac, how's it going? That's all good, anime. No worries. Do what you gotta do. Sounds good. Yeah, next stream will be tomorrow, same time. Any advice on starting out on Python, and what's your fate? Well, I don't know what your fate is, Brian, because I mean, it depends on how much work you put in and the stuff that you build and the connections that you make, I think. But any advice on starting out on Python? I think if you have never used Python before, I think a great resource is Free Code Camp. You can start learning. It's gonna make me log in. Let me just go to the curriculum. But you can start with the Python cert here, and this will get you basics. Get you the basics of Python, if you've never done it before. And if you've done a bit of Python, then I would recommend just practicing by either doing like solving DSA problems on something like Code Forces or LeetCode. If you want to get better at DSA, if you want to get better at project building, then maybe Google some example project ideas in Python and just work on them. Build a portfolio of things. Like just start building stuff. Like it doesn't even matter what it is. Like, just come up with project ideas that interest you and start really small. That's the other important thing is you have to start really, really small. Do something that you could do in an hour or two to begin, and then do a few of those, and then you get really comfortable with the smaller scopes projects, then up the scope a little bit, and then up it and up it and up it, and then eventually you'll get better and better. So, all right, so that we got the deletion for the binary search tree working. This is a really convoluted iterative function for the deletion, but it does work. So yeah, no problem, Brian. Okay, so is this self-balancing? No, the deletion is self-balancing, JMac, but the insertion is not. The insertion is naive, but the deletion is self-balancing. So basically we check whether the node to be deleted has no children, in which case you can just get rid of it. Whether it has one child, and then, or if it has both children, in which case you need to, like for example in this case, like we're deleting 9, but what we do is we find the leftmost node in the right subtree, which is 67 in this case, and then we replace the value up here with 67, and then attach 67's right subtree to this node here, because this node's actually is the one that's actually getting deleted, and we're replacing the value of this node. But the deletion should be self-balancing, I would think. But the insertion, like if I insert, like just as an example, if I insert like 5 and then 6 and then 7 or something, then actually that's a bad example, because it's going to reconstruct the tree. 5, 6, 7, 8, maybe. But you can get like a chain of sisters here. So 8. Okay, I'm actually doing a bad example. Let me do like 325, 326, 327, 328. Yeah, see here? You get a chain of right children with the insertion because it's naive. But basically what we're going to have later on in the project is a rebalancing function. Oh, Gil, how's it going? I hope you're doing well. But no, we're gonna implement a rebalancing function. So that's fine. Okay, so then let's do this. Maybe I'll add like another node, like 66, something like that. Okay. So we have to do this level order for each. So this is basically just a breadth first search on the tree. And then we need a callback function. So that's fine. So we'll just do if callback is undefined, then return or throw new. We need to throw an error, I think. Throw an error. Okay, so throw new error requires callback function. Let's say level order for each. Okay. Something like this. You're doing fine. I suppose yesterday was a rough day. Oh, that sucks. But I'm glad you're doing better today. Yeah, days they go up and down, right? I know for me, usually the beginning of the week is harder, but okay. So let's do our. We can do it with a queue, I think, right? Because if we have a first in first out queue, then we can essentially push, like, the iteratively push children into the queue. So I think we can do something like const queue equals. We could probably implement a queue with trying to think how we could do this actually. How's it going with my coding journey? Last time you were here, I was on the linked list. Yeah, so we're on to implementing a binary search tree now, Gil. Yeah, especially at work. Yeah, exactly. I know the drill. But yeah, so we finished the linked lists, and now I'm on to binary search tree stuff. So I'm implementing functions for a binary search tree class. So I just got done with doing the delete node function, which took a while, but that's done. And now I'm working on this breadth first search traversal, and I'm debating whether I do it iteratively or recursively. I think I'm going to do it iteratively because that's kind of what I've been doing thus far. I just need to figure out how to make a queue work in JavaScript, or if there's a base type for a queue. Oh, I could use it with an array, and then there's like a dot shift or something. It removes the first element of the array and returns. Oh, so that's how we do it. Okay. So we'll set it as an array. It'll be an array of nodes, I think, though, right? Encoded a queue with your linked list in the linked list integrally. I could do that, Gil. I could do that. Probably make one in-house with an array or linked list. Yeah, JMac. I can use there's this function called array.shift. Which is essentially like dequeuing a queue, right? And then I can just push a value to in-queue it. So if I push a value to the end, that's like in-queuing, and then if I shift it, that's like dequeue. So I can do a queue with just an array. Okay. So let's do this. So then what we want to do is we want to push the or actually we'll say like node equals let node equals this might be easier to do actually with a provided like node. So maybe we do this recursively. Although maybe not actually. No, we don't need to, because if we're pushing nodes onto the queue, then we don't actually have to do this. Sorry, I'm just backwards. Okay, let me see. You can have an internal function that does the recursion. I can, Gil, but I think I'm going to do this iteratively. because I've been doing like this. My delete node function was iterative. It was kind of a mess, but I'm trying to do iterative solution. I mean, I could do recursive ones too, but just for practice, I'm trying to do this iteratively. I could do the other ones recursively though. Okay, so then what we need to do is we need to do q.push this dot root, I think, right? Odin says that, Gil, but I don't listen to Odin completely. It says that, it says try implementing both. It doesn't say you have to. So what I might do is I might do this iteratively, and then the other depth first ones I might do recursively, right? So I don't know. I don't really, it doesn't bother me. The logic's the same either way. Okay, so then we'll do while q dot length is greater than 0. So we have to make sure that there's always something in the queue. And then we'll say let node equal q dot pop, or not pop, sorry, shift. So that'll dequeue basically. And then we need to do our callback function, assuming that the value exists for that node, which it should. And then we just we add the left and the right children. So we'll do if node dot left child, then q dot push node dot left child, and then the same with the right child. Oops. It's gonna yell at me because cost fine. There we go. It's BFS, Gil, because we're using a queue. So essentially, the callback is happening before the children are pushed onto the queue, right? Or in queued. It is BFS, yeah. It's BFS, iterative BFS. I think this should work though. I think this is all we need, because then I can do like a, let's define a callback function. Let's say callback function let's just say n number equals, sorry, do it like this. Console dot log n, right? Or something like this. And then we should get the values of the tree printed out in order, in level order, right? So like, to use this example, we should get 7, then 3, 66, 1, 4, 9, 67, 5, 3, 24. I think. Maybe actually we could do it like this. We could do const array of number, and then we could actually just array.push. And then, so that we can print them all out together. And then I will my tree dot level order for each callback function. Whoops. And then this should work, I think. Okay, well, it didn't quite work. Oh, because I didn't actually print the array. Right, that's why. Okay, so 7, 3, 66, 1, 4, 9, 67, 5, 20. Okay, it worked. Okay, that was pretty easy. Okay, all right, okay. So, I mean, it's pretty similar logic for the other functions, right? Yeah, 6, 7, exactly. I wonder if they did that on purpose. I wonder if in the example they put 67 in the... I wonder if that was tricky from them doing that on purpose. Okay, so that's good. Make this, oh boy, I need to make it a function type. There's probably like a way of doing that. Let me look up function types, TypeScript. I don't know how to declare, oh, I see. Okay, so I can do this. So I can do like n number and then void. There we go. That's better. This is still giving me shit. I don't really care about this specific. It's a TypeScript thing because this could be undefined. Blah blah blah. I'm just gonna leave it. Might cause problems later on, but I don't think it will. Okay. Actually, you know what? I'll just. Is there a way of doing it? Like, can I do it like this? Yes, that fixes it. Good. Because this exclamation mark asserts that it's not undefined, I think. But it doesn't work with this. I don't know why. Node is possibly undefined. Node.value, but that's weird. Okay. Oh, so it'd be this, maybe. That's it. Okay. There we go. Okay. I'm learning how this works. Okay, so then we'll do the in order, pre-order, and post-order. So I think these all that also accept the callback. Each of these functions should traverse the tree in their respective depth first order and pass them each value to the provided callback. Function should throw an error if no callback is given. Okay, so then we'll just try and do this blind here. So we'll do in order. In order for each. Oops, that's not what I wanted to do. No. Just trying to duplicate. There we go. Pre-order. And then post-order. So I'll do these ones recursively, I guess. It's pretty much the same idea, though. I just have a helper function inside. I'm just going to do this error handling as well. Pre-order, post-order. Okay. So let's do in order. So in order would be like 1, 3, 4, 5, 7, 9, 66, 67 through 24, I think. Right? So I think what we can do is we can have a helper function. So we'll actually get the queue here. And then we'll say const in order equals this. We'll pass in the queue as a node. And then actually, I may not even need that. I think it's within scope. Maybe just give it the node or something. And then we'll say q dot push this dot root. Actually, no. I need to do that here. Q dot push node dot, or Q dot push node, and then Q dot left if Q dot left child, or not Q, if node dot left child. So we need to push all the left children on first. So we'll do in order node dot left child, and then we'll do the right child. Right. And then we can just dequeue them all, I think. So I think we can just call in order of this dot root. But then I need to figure out when to actually I could probably do this within the or do I do the, how do I do this? I'm just thinking about where I actually do the callback calls. Oh, you know what? It would actually be like this, would it not? Oh, no, it wouldn't. That's fine. And then I would need to, maybe I would dequeue it here. So we'll say callback q dot shift dot value. Actually, no, that's the bad way of doing it. I think if we actually fill up this queue and then we just go through it and print out each of the values, that'd be fine. So we can do like while q dot length is greater than 0. I think this greater than 0 is actually unnecessary, because if it's 0, then that will return false. Okay. Then we'll just say let node equal x, or just const m equals q dot shift, and callback n dot value. Okay. Although, could I do it like this, I wonder? Yes, I can. And I just do the callback here, because this is where all the enqueuing happens. recursively. And then I think this will work. So we'll do in order. So then we should get 1, 3, 4, 5, 7, 6, or 7, 9, 66, 67 through 24. Nice. Okay. Turns out I can do depth first search blind. Okay. And then I think the pre-order is, let me just refresh on what the pre-order is. Oh wait, I don't need to see. Let's just see. Just refresh on this. Pre-order. DST. At first visit the root, then traverse left subtree, and then traverse right subtree. Okay, so then pre-order would basically be the same as this. Oops. Pre-order. And then we just put this up here. And then post order is the same, but then the queued up push is at the bottom. I think. Or is it, no, it's right child, then node, then left child, I think. Oh, sorry, left, then right, then child. Or then root. Okay. Yeah. So then pre-order for this would be like 7, 3, 1, 4, 5, 66, 9, 67 through 24. Seven, 3, 1, 4, 5, 66, 9, 68. Yeah, perfect. That works. All right, I'm gonna hit. I'm gonna go to the washroom real quick, and then we'll do post order, which is basically the exact same as this, and then we'll move on to height, depth, and is balanced and rebalance. So cool. Alrighty. So. All right, I'm back. Okay, let's just start this here. Okay, post order. Whoops. It's the same. So then we just do this. And call this post order. And then should get 1, 5, 4, 3, 9, 3, 24, 6, 7, 6, 6. Yeah, that looks right. Because we're doing the leftmost subtree, then the right, then the root. Yeah, it is more simple. I guess I could just change this one too. I mean, this one's not that hard. Like I could do this recursively too. So let's do that. We could refactor this to be recursive. So we can do const level order node, and then we'll say I think I could actually just do it the same. Because it's the root, then the left, then the right. BFS is generally easier iteratively. DFS is easier recursively. Yeah, that's fair. I mean, I could try to refactor this to be recursive. I did not know that though, JMac. That makes sense. Like I think I could do that. I think I could do it just very simply to this. Like I think I would still need the while loop in here. I think. And then we say callback q.shift.value. And then we just do this. Oh, actually, wait. We queue it first. So we'll do q.push node. Oops. And then I think this works too. But then instead of obviously pushing here, we just recursively call level order. This might not work exactly how I think it will though. Oh, it does, JMac? Okay. Well, I'm just using it for learning. Actually, I don't know if I need this. I think it's just not a while here. I think it's just if. Because we're not looping. I don't know, this might not work exactly the way I think it is, but I'll just leave it, comment it out, and then test it. So we'll say level order this dot root. Oh, and then we need to change this level order. Oh no, it didn't work. You know what? Fuck it. I don't want to. It's too much of a headache. I could probably do this, but I don't really feel like wasting more time on this problem. What's the problem here? Level order. Oh yeah, 7, 3, 6, 6. Yeah, that works. Okay. Good. Okay, so let's do the height and the depth. Value, or no, number. So we'll do height. Returns the height of the node containing the given value. Height is determined as the number of edges of the longest path from that node to a leaf node. If the value is not in the tree, the function return undefined. Okay, so this we could do recursively, I think. Right, so we can do we can just do a helper function inside that we call recursively. Yeah, it's just for practice. That's exactly what we're doing here. Okay, so let's start at the root. So we'll say, actually we should have a helper. Let's just do const height recur equals, and we have a node in here, right? And then we're going to ultimately end up calling height recur on the root. Right? Actually, we're going to say let height equal this. And if this returns nothing, then we return it. Return height. Actually, we can just omit the variable altogether. Just return height recur on this dot root. That's good. Yeah, fair, JMac. I could implement a queue, like manually, but no, I hear what you mean about the shift, because it's O of n, because you're basically shifting the index 1 to the left for every value, so you have to traverse the entire list. If that's the way shift is implemented. I see what you're saying, why it would be O of n. Yeah, like if I implemented a queue with a linked list or something, then it would be constant time removal, because you just remove the head, right? No, you'd remove the tail of the linked list to get to DQ, and then to NQ you just add head to the front. You just prepend. So that's how you would do a queue data type with linked list. But I already kind of know how to do that, so it's kind of practice. Plus, the data that we're working with here is really small, so it's not incurring much of a cost. Okay. So what we want to do here is we want to like have a variable. Just thinking about how to do this. We could do, to prevent, we could just do this. We could just say if includes, if not includes value, then return undefined. Otherwise, we have height value. Or no, we don't actually need that. Okay, so we need to check whether the if node dot value, or if node dot value equals v equals node dot value, then we found it. Let height equal 0. Then we just return height, call a day, else if v is greater than node.value, then we call height recur on the what subtree. So if the value is greater, then you'd want to go to the right. So we do a node.rightChild. And we know that the right child exists because otherwise we would have returned undefined here. It's not the best way of doing it. And then we just do else. Actually, I think I can do the height increase. No, actually, I'll keep it like this. Height recur node dot left child. We can just return height actually. We just call this function and then return height. There we go. Returns the height as the number of edges in the longest path from that node to a leaf node. Oh, sorry, wait. Actually, I miscalculated. This is actually depth. This is what I'm doing is depth, not height. I didn't think about that. Depth. I just implemented depth without thinking about it. Oops. Depth, recur, and then return depth. Okay. So the height is a little different. It's from that node to the leaf node. So then we need to find it. Now I could do this. I could do the same here. So we need to find the we need to find the node first, right? Which we could honestly just do iteratively. Oh, yo, Wade, how's it going? Appreciate the sub. So we'll just say let node equal this dot root. And then we'll say while node if node dot value, or if v equals node dot value, then we do that, else if, and we'll do the else ifs here. V is greater. We'll do node equals node dot right child. Otherwise, node is node dot left child. Okay. So we basically find the value, or the node where the value's at, and then once we find it, then we can do a recursive thing. So I think we can define a depth function, depth relative or something, and then we'll do like a depth as a number and then a node. You don't know how or why or when you ended up in the position you're in. You're starting to feel distant. You can vent, Wade, as long as you're not inappropriate. You can vent about stuff if you feel like it. As long as you're not, there's nothing controversial or anything like that. Like if you want to just like vent about whatever, you can go for it. Okay, so then we'll do. Okay, what do you mean that you're done with life? I can assure you you're not done with life, Wade. You can use me as motivation to keep pushing. Like what are you trying to accomplish? Okay, so let me just think about this. So we'll just return max of depth relative. Actually, we'll just say if node return 0. Otherwise, we'll say return maximum of depth relative d plus 1 node.leftchild, and then the max of the right. Right. Math.max. There we go. So I think this works. Oh, sorry, it's n. I've been there before, Wade. I know how you feel. But it's okay, man. Okay, so I think this works, actually. So then if this is true, then we can do, let heights equal 0. So we don't even need it here. We can just do return return depth relative for the current node value 0 and node, I think. So if the value is not, okay. So if the tree, why is it still not working? Depth relatively implicitly has any type. So it should be a number. There we go. Okay. But I think we want to start this at... if not, node return. Actually, we don't want to return 0. We want to return D, right? That's what we want to do. However, this means that a leaf node will have a height of 1. So we actually probably want this to start at -1 because then the leaf node will have, although no, that's fine. Because -1 plus 1 is 0. So it'll be 0, max 0, and 0. So it'll be, so a leaf node will have a height of 0. And then a non-leaf node will have a height of at least 1. I think that works. I appreciate that, Nathan. I honestly don't know who that is. Grant Cardone. Oh, he's an American businessman. Interesting. Cool. Never heard of that guy. But no, Wade, it'll be all good. Just remember that whatever, and I'm not the best motivator when it comes to tough stuff like that, especially to strangers on the internet, but I can almost assure you whatever you're going through now will pass if you want it to. Like if you want to change for the better and you're really motivated to do that, you will find it within you to change. I didn't think that was true, but it is true. I promise. Anyway, okay, so I think this works now. So if we get the depth of, like, let's say the depth of, like, 7 should be 0, right? Oh, my tree depth, sorry. Yeah, so it's 0, and then the depth of 3 should be 1. Good. The depth of 324 should be 1, 2, 3. Good. The depth of 9 should be 2. And then the depth of 8, which doesn't exist, should be undefined. Yes. Perfect. And we'll do height as well. So height, so the height of a leaf, like 5, should be 0. Okay, hold on. Cannot read properties of undefined. Okay. Because it is undefined. Okay, so I might need to actually change my approach here. So I'll say let max left depth equal depth relative d plus 1 equal, actually we'll say n dot left child depth relative d plus 1 n dot left child, otherwise 0. And I'll do the same for the right, max right depth. I want these to be constants. Right child, right, and then we do math.max between the lefts, max left depth and max right depth. Okay, good, that's what we want. All right, so now we have 0 for the leaf node, so then something like 4 should have a depth of 1, or a height, sorry, my bad, not depth, should have a height of 1. Still a 0, okay. I'll think about that. I'll just console log it. Interesting. D+1. Oh, because I know why. Because we have this condition here. I think that fixes it. Oh no, it doesn't. Okay. But it's being called twice, which tells me that this depth relative is being called. Max left depth. Oh, node or undefined. And then I could do what I did before. I think. Yeah, I'm gonna do depth relative D+1, and then n dot left child. Oops. I think this actually will work. And we'll say if non-node, then return D. And we start at -1. Ah. We have an infinite loop. Interesting. Okay. I'm just gonna think about that for a minute. Actually take the break. How many more functions do we have? Oh yeah, is balanced and then a rebalance. So a binary tree is considered balanced if for every node in the tree, the height difference between its left and right subtrees is no more than 1. And both the right and left subtrees. Okay, so this is I think I can implement the rest of this. The rest of this binary search tree by the end of tonight, and then I'll do the. We'll go on to the Knight's Travails as well, which is also just another breadth first search problem. So. We also might generate test sets for testing for this problem specifically. Just so you know how I would do it. Find the node using traversal lookup. Are you talking about the function that I'm currently writing, like the height function? Because what I'm trying to do is basically, I don't know. I think what I have is maybe similar to that, but I'm doing a traversal to find the target node, right? And then if I find it, then I find the maximum depth of all of its, so the maximum depth of its right and left subtree. Because then that'll give us the maximum height, which is ultimately defines the height. That's kind of what I'm doing, sort of. I think I'm getting a infinite callback here. Yeah, it is the same. That's what I thought. I'm just trying to figure out what the problem is. Because this early return condition should prevent infinite recursion here. Because in the case that node is a leaf, you get this passes, but then these both return 0. Because d plus 1, negative 1 plus 1 is 0. I'm wondering if I actually omit the question mark. Because n can be undefined. Cannot read properties of undefined. Oh, I see. I wonder what the question mark does. Does that just let it be undefined? Because I thought I knew what it was. Is a safe navigation operator. It prevents object class from undefined. Oh yeah, okay, that's basically what I thought. Oh, so I can actually just do this. Maybe. See the name of the variable at 226. Oh, thank you. Thank you. There we go. Yeah, you're right. It should be n because I called it n because we already have node up here. You're right, Gil. Yep. Yep. You're right. Okay, so that works now. So the depth or the height of 4 is 1, which makes sense. And then the height of 3 should be 2. Good. And then the height of 7 should be 3, I think. The root. Nice. Okay. That was a tough one to debug. Yeah, that was just me being negligent, Gil. That was just me being negligent. Because of the naming, the weird naming I have in here. Because I have node for the outer function, and then n is just the inner function. Okay, cool. All right, so now we did the height. I think the height works fine. Because then if we did 66, then the height should be 2. Yep. All right, so I trust that this is fine. And then let's just check the leaves again. Yeah, the leaf is 0. Good. Okay. That's what we want. Okay, so then we need a balanced. Is balanced and then a rebalance. And then so the good news with these last two methods is we can probably use the previous methods that we wrote to help us with this, right? So we can actually use the height, specifically the height function that we just wrote. I mean, it's like extra time complexity, but I think it's fine. Okay, so then we could do we could do this recursively as well. So we want to return true if it is balanced, otherwise we return false. Right, so we'll ultimately have like return true at the end. Okay, so then let's do this. So let's say const check balance for a node, right? I keep forgetting arrow syntax. Okay. And then we say that I don't want this. Higher trees can, for every node in the tree, the height difference between its left and right subtrees is no more than 1, and both the right and left subtrees are also balanced. Actually, we might want to do this check height difference or something. Every node in the tree, the height difference between its left and right subtrees is no more than 1, and both the left and right subtrees are also balanced. So we might need two functions here, actually. This, in a way, is my favorite DSA. It's hate-love situation. More hate than love. Yeah, that's fair, Gil. But I think let's start with the checking the height difference. I'll just call it, like, height diff, just to make it easier. Actually, I don't even maybe need this function now that I think about it. So we have like a let node equal no this dot root, and then we say if height. Actually, we can just do it. We can just do it like this. While node. Oh no, we actually can't do it like this because I'm just thinking this through multiple different ways. Okay. Right, this dot root, and then we'll say, we'll get the height difference. We'll say if height, this dot height of this dot, or node dot left child minus this dot height node dot right child, and then I need to do the math dot absolute of this, math dot ADS, and then if this is greater than 1, wait, the brackets are wrong here, I think. Then we want to return false. Otherwise, we return the we want to check the balance of the left and right. Object is possibly undefined. Just don't worry about it, bro. This is possibly undefined. This. It's gonna give me trouble. No, node. Non-assignable to parameter type number. Height. Oh, because it's the value. Right. That's what we want. Okay. I'm getting better at this, I think. Maybe not. Okay. And then we want to return. We actually want to do this. We want to do if check balance node.leftChild and check balance. Actually, that's what we want to return. Return check balance node.leftChild and check balance node.rightChild. So we want to make sure both are balanced, right? We return that as a Boolean value. Okay, and then this returns a Boolean. All right, so this should check whether it's balanced or not, I think. So this tree, I think, would be balanced. Can't read properties of value. Why? Undefined reading value. Oh, because I see. Because node.leftChild might not exist. You can get around this by tweaking this. What if I'm in a leaf node? Yeah, that's what I'm working on right now, Gil. So I need to actually explicitly get values for these. So I need to say const left height equals node.leftChild. This dot height node.leftChild dot value. Otherwise, it's 0. Right height is node.rightChild. This dot height node.rightChild dot value. Otherwise 0. And then we'll say math.absolute node.left minus node.right. Left height minus right height. What's the problem now? Left height is possibly undefined. No, it isn't. Okay, now we're in big shit. Oh, because the bracketing is all fucked up. Uncaught type error. Cannot read properties of undefined. But that should be caught here. Right? Because if this is undefined, then we set it to 0. So I don't know why that's causing trouble. Oh, because I see. Because of this. This is the problem. We can do a preemptive return. We can just say if not node, return true. There we go. Okay. Okay. I think that fixes the problem. So if we pass in invalid, like if the node's undefined, then we return true. This is still giving me shit. Because I don't know why this is not. This should be defined always. Because the default's to 0. And then if we add like 325 and 326 to this, this should not be balanced. Oh, see? Okay. Oh no, it still is because it's restructured. Okay. 327, 328. Ah, because it's constructed. Okay, you know what? We actually... need to myTree dot insert node 25, 26. Yeah, so now it's not balanced. Okay, good. Good, good, good. Okay, so the balancing should work fine. So it's balanced up here, but then here it's not because of this tail, right? So I think that's fine. So I still don't understand why these are yelling at me. Like, do I explicitly type it here? I just don't know why this would be undefined if it's yeah, so it works. It's just I don't know why, because like we check whether the node.leftChild exists, and if it does exist, we get its height. Otherwise, we set the value to 0. So I don't know why these are possibly undefined. So I don't know. It still works either way. It's just like a TypeScript thing. But that's fine. I trust that this works. And then the rebalance is pretty easy. We actually pretty much just do what we did with the... yeah, it's weird, eh? Because it's like, I use a ternary operator to set the height to 0 if the left child does not exist. So it should always be at least 0. How's it going, Ayush? I hope I said your name right. Let's just return false here. Okay. Oh, okay, sure. Yeah, I can try that out. No, still giving me an error. Right height is possibly undefined. Oh, restart the server, you mean? Okay, I can restart the server. Yeah, it's still the same. Interesting. Interesting. I don't know. Yeah, here's the code. It's just a ternary operator. Because again, the code works, it's just a TypeScript thing. but the rebalance should be pretty easy. Can left child be undefined? Yeah, it can be, because if it's a leaf node, right, Gil, this will be undefined, right? My thinking is if this is undefined, then we go to the false click case and then set left height to 0, right? I'm just doing this instead of an if-else because it's ternary operators more condensed, simpler. So it has a default value here. So like if this condition's false, we set the left height to be 0. And same with the right height as well. Because left child can be undefined for a leaf node, for instance, or a node like 324 where 324 does not have a left child, right? It has a right child, but it doesn't have a left. But yeah, I don't know. I might just table it for now and then get working on the rebalance. So the rebalance is pretty easy. So we basically just do, can you hover over line 262? Yeah, sure. I can also write on node left child. Oh, like this? Yeah, it says node left child is node or undefined. That's the property. And that's how I define the property in the node object. I'm wondering if it's because node. I'm wondering if it's like something to do with asserting truth here. I don't know. Oh, maybe. Try that. Still didn't change anything. I don't know, cause don't let him say you ain't beautiful. What are you talking about, Wade? Okay, so yeah, I don't know. It's kind of weird. I'll do this rebalancer one, because this is gonna be pretty easy. Because we can just use the pre-order. I think the pre-order will get us a sorted array. Can value be undefined? Maybe. Although I don't think so. It says it's only number. So, like if I go to the node definition, value is only ever a number. Value cannot be undefined. Because when you're constructing a node, you have to give it a value, right? Yeah, I'll just leave it. It functionally, the code works, so I'm not too concerned. But with this rebalance, essentially what we can do is if we get the pre-order, if we do a pre-order traversal of the tree, then we get the array in sorted order, and then we can just rebuild. We can just rebuild the tree. We can call build tree on the new sorted array. So that would be pretty easy to do. So I think we can do that, no problem. So we can essentially just do basically just this. Sorted. And then we'll do, that's our callback function, add to sorted array or something. Push. I don't know, something like that. And then we can do this dot pre-order for each push to sorted array. So we can call that. And then if we console.log sorted array, then this should be a sorted sorted array, right? Why? Maybe not. 7, 3, 1. Oh no. Or is it in order? Sorry, it might be in order. In order? Yeah, that's it. It's in order, not pre-order. My bad. Click through the YouTube rules too fast. Did it say something like no backseating? Yeah, Razor. However, no backseating if I explicitly... I should probably update it, because that was earlier on, Razor. No backseating if I explicitly say so. But in cases where I like ask for help, then that's fine. But if I should update that, to be fair, because that was when I haven't touched the rules since I first made it. But I have actually learned that through streaming, I appreciate the help that some people give me, and it helps me learn faster. Feels odd since you don't know this, but it will be fun to study TypeScript. Yeah, it is fun. You should go learn it. Can I do Command-Shift-P and search for TypeScript and restart TypeScript server? Sure. Whoops. Wrong. I did Option-Shift. That was not what I wanted to do. That fucked with my Windows. How much time do you need to become AI engineer without degree? Long time. I don't know how long. Depends on how hard you work, I guess. Command-Shift-P, and then what was the command you said? Restart TypeScript server. No. Didn't fix it, Gil. Did not fix it. Okay, and then this is the sorted array. Okay, and then what we could basically just do is we can call... where's my constructor? This dot root equals this dot build tree. Yeah. So we can just rebuild the tree. Sorted array. There we go. And then we can console or pretty print this dot pretty print my tree dot root. Right. Or this dot root, I guess. This dot root. So there, I think the rebalancing worked. Yeah, that's fair, Gil. You see, the other thing too is like I work 8 hours a day, right? So like I'm coming to this stream and I've already put in like 8 hours of like in my day job. So like I don't know, I feel like I'm not I get you. Like I feel like I'm not as quick as normal. When I'm doing this stuff, like, or if I'm doing this on a weekend or something like that. Like today I was in like a shit ton of meetings, so I don't know, I'm kind of burned out a little bit on work. I'm not burned out on this, but I'm burned out on my job a little bit. But anyway, this worked. So you can see here that we had this big chain, and then it rebalanced it here. So, and then now if I print is balanced, then it should return true. Yes, perfect. So balanced, added some nodes, not balanced, and then rebalanced, and then it's true here. The couch moves 0 miles an hour. This practice is great. What do you mean? What do you mean the couch moves 0 miles an hour? I've never heard of that expression. But it is good practice, though. I would agree with you. Yeah, I should update. Now that you mention it, I should update the rules. Can I change that? Let me see. I'll do it after stream. Settings, no. Yeah, I'll change it after stream. You're saying, what do you mean by like not progressing? Are you saying I'm not progressing, or? I don't know, sorry, I'm just confused. It's been a long day. Whoa, that's not what I wanted to do. Oh, you're saying I am progressing. Oh, I appreciate that, Razor. Sorry, it's been a long day. I've been awake since like 7:45 in the morning, so. Right, I see. Okay, I got you. Sorry. I understand now. Anyway. Okay. No, I appreciate it though. Yeah, so I think I'm gonna end it here for tonight, only because I do 5 Pomodoros during the week. I think that's like a good value because 6 is a lot. It's 3 hours. After an 8-hour day. It's actually 9 hours if you include lunch. I mean, I do work from home, but it doesn't change that it's still an annoying job. But hence why I don't want to give away anything about my location, because if my employer finds out that I'm complaining about work on the internet, they're not going to be too happy about it. But anyway, I think I'll just commit this. I wasn't really doing regular commits. Git push. Okay. I don't care about this TypeScript error. I'll just leave it. Okay. So then I'll add my solution to the thing. Where is it? Odin BST. We'll figure it out, Ben, eventually. Yes, I appreciate it. I appreciate that. Yeah, we will. I could even like debug this at the beginning of next stream if you want. Or if you'll even be here, I don't know. Cuz I don't know why this isn't. I mean, okay, I'll do one thing. I'll do one thing before I go. It's best I get some rest. Hopefully see you around. Yeah, Razor, if you want to subscribe to catch future streams, then go for it. I would appreciate it. If you're not already subscribed. I just want to see if not using a ternary operator fixes the issue. So we'll say const left height. And we'll say if node.leftChild is not equal to undefined. Then this dot. Okay, I wonder if this fixes things here. Cannot assign to left height. Oh, let left height, sorry. That's so weird. I just refactored it to an if else. And it didn't fix it. I appreciate that, Razor. Okay, I'm just gonna let that sit. I don't know why that's not working. Okay. This dot height, what does it return? It returns a number or undefined. Oh, I see. Maybe what's the problem here? Because this dot height can return undefined. That might be why. I didn't think about that. I forgot about this clause here. Okay, so then what we can do is we can. Yeah, it can return undefined. So then left height might be undefined. Yeah. Even though it would never happen because, we're using a value that already exists in the tree, so it would never happen. But I use this to prevent calculating a height of a node that doesn't exist. Okay, so we can easily check that. So we can say like. So instead of returning undefined, I could just like, for a node that doesn't exist, this is going to be a hack. Instead of for a node that doesn't exist, we can return a height of -1. I know that's not technically what the implementation was supposed to be, but now it always returns a number, and then I think it should fix the error here. Because I don't think now it can return undefined. Can it not? I don't think so. Let me see. Wait, back down. Return. Yeah, I don't think it can return. It can return a... Okay, so I don't know still why it's not working. Left height as a number. On line 221, put number after the parentheses. Oh, I see. Okay. Function lacks ending return statement. Return type does not include undefined. Oh, I see. Well, the ending return is here. Oh, otherwise return -1. Okay. Well, let's have this. Yeah, but if I did that, if I did it as number or undefined, then we'd have the same errors before. Okay, so that fixed it. That fixed it. Okay, I'm gonna refactor it to what I had before. All right, we got it. We got it. Because I can just like, even though the here, let me just fix this here. Perfect. Now we can rest. Exactly. But the thing is this return -1 on line 238 is never going to be reached, right? It won't ever be reached because this will catch it first. The code doesn't know that, but this would technically never happen. Because if the value doesn't exist in the tree at all, which this checks, then it'll return -1 up here. So if we get past line 222, then we know it exists somewhere. Oh, you can, Razor, exactly. That's the beauty of it, is like, you know, there's multiple ways of approaching it, but this technically fixes our issue. Might be worth thinking about type of should we when you're rested. Yeah, that's fair. Because again, I'm just kind of doing this whole thing like, what's the term? Like ad hoc. Like I'm kind of just doing it as I go. I'm not really like improv. Or impromptu. Like I'm just doing this impromptu. Like I'm not really like thinking it through first. I'm kind of just thinking through it as I write it, right? No, I agree. You know what? I might come at this maybe tomorrow, and we can refactor it or something. Because I'm sure this could be refactored to be better. But oh, sure. Yeah. Okay. Cool. All right. Yeah. I think for now we'll leave it here. 8 hours of work and 3 hours of study is a lot. It is a lot, Razor. I honestly. But you know what though? I have such a what's it called? Like I have such a passion for doing what I'm doing and growing this channel. And I know it's still small, but I want to get out. I really like what I do with this. Like it's really fun. Plus, like having a community now, it's kind of cool. I really also just want to break into tech as well, like software development specifically. Like my current job is not the long-term goal. I wanna do my own thing, whether it's content creation or, like content creation related to programming, whether it's maybe tutoring, maybe I start, join a startup or something, or even get a job as a developer. I have no idea. I'm kind of open to whatever and just kind of exploring my interests as I go. But right now, this whole content creation thing is kind of cool. Oh yeah, dude, Razor. I started my first degree. I did a first undergrad in biology as well. Exactly, exactly. There's multiple branches. But no, my first degree is in biology because I thought I wanted to be a teacher. Uh, which and then I was like, ah, fuck that, and then I went to computer science. Um, my biology was a little different. I did ecology, like so my specialization was like ecology, forestry, uh, like biogeochemistry, stuff like that. Like it was like uh, my term paper for my final year was like writing about nitrogen and phosphorus transport across riparian zones from agricultural sites to lakes. Uh, like a riparian zone is kind of like a wetland between like a farm and like a body of water, and then so I was like kind of researching nutrient transport through like sediments and stuff like that. Um, oh, nice. Oh, just under a decade. Wow, that's fair. College is all Greek. Yeah, it's cool. Don't get me wrong, it's cool, but it's not what I want to do like for work, right? Um, I'm just gonna re-push this. Fix type error with was it the rebalance with is balance and height functions. There we go. Yeah. Anyway, um, I'm gonna probably head now, but I appreciate everyone coming and you know helping me along. I'm gonna update the rules for the no backseat coding thing. I think because backseat coding's good when it's actually like good advice. I don't just want people like it's more of a nuanced thing. I don't want just people just telling me the answer. I want to like people to like help me think through problems, which is what you guys have been doing, by the way. Like it's been really helpful. Um, Maybe just Socratic, yeah. Um, Kind of, yeah. That's like you mean in the sense of like ecology or the backseat programming. Um, but anyway, whoops. Like lead me to the answer. Yeah, exactly, Razor. That's kind of what I mean. Because like I do learn a shit ton from you guys helping me out. Um, and I feel like it's especially with getting used to TypeScript and stuff like that. Um, so I'll make a more nuanced thing, but it was like when I first started, I didn't know what kinds of folks were going to show up to this channel, so I just was like, oh, I'm just gonna say no backseat coding. And I also was way more shy back then, so I wasn't as open to feedback. But part of I think why people like this stream is that they can kind of interact with me and help me with things, and we can kind of have a back and forth. I think that's why a lot of people get, they get a lot of value out of it. But anyway, I'll leave it there. I'll be live tomorrow around 6:30 p.m. between 6:30 and 7 p.m. Eastern Daylight Time, UTC -4, and yeah. No, that's fair. I think maybe if I'm working on a more serious project, maybe that I might ask that. But for the learning stuff, I honestly appreciate the help. But yeah. Anyway, as I said, I'll be live tomorrow, 6:30 to 7 p.m. EDT, and yeah. If you want to join, I'll see you then. And otherwise, have a great rest of your evening or early morning if you're in Europe or Asia.